Today I will be going over question B in homework 12. Question B in homework 12 reads, you are given a permutation P of length n. Find a permutation Q of length n that minimizes the number of pairs ij, where I is greater than or equal to 1 and less than or equal to j, which is less than or equal to n, such that pi plus 1 all the way to plus pj is equal to qi plus 1 all the way to plus qj. A permutation is a permutation of length n is an array consisting of n keyword distinct, we'll get back to that later, integers from 1 to n in an arbitrary order. So basically the question is asking us to receive an array like 1, 2, 3, 4, 5 and produce an output array in which you cannot find a subarray with the same summation. For example, if I pick 1, 2, 3, that adds up to 6. So that's the first three numbers of this. And the first three numbers of our output should not be equal to 6. Now, let's visualize this. Let's go there, and then let's think about what our output has to be. Now, here is the way I thought of it. We are lucky that permutations have keyword distinct values. That means if we take a subarray with every value that's the same, let's add another one. Every value that's the same in the subarray as the output, except for one number, we know that the sum will be different. So let's take this subarray for example. If we want to change it, we can go there. Now we have 1 and 2. 1 and 2, that's the same. So this is not a viable answer, but just to help show my point, I'm going to use it. 1 and 2 and 1 and 2 are the same, but 3 is not the same as 4. So this subarray will not be equal to this subarray. So I thought to myself, how can I create an array in which each subarray has the same numbers except for one number? And we have to switch up the order, because if it was like this, the subarray 1 is equal to the subarray 1. So what I did was I rotated the array. I moved the values 1 to the right. So okay, so actually let's move it 1 to the left. That'll be easier. We can move it 1 to the right. I think there are many different ways to do this problem, but let's go here, 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 and then we take the first index, so this index 0, and we move it to the front. By doing this, we've ensured that each subarray will have at least one different number. In this case, in the first three numbers, it is 3 it is 1 and 4. Those are different numbers, and thus this subarray does not equal to this subarray. This subarray, 2 is the same, but 3 and 1 are different numbers, so the sum is different. 1 plus 2 is 3, 2 plus 3 is 5. So let's see how to code this problem. It's a simple rotation problem, so first, obviously, we need our test cases. We need our test cases, right? And then we want to loop through the test cases so that we can get a different value for each test case. So we want to loop through the amount of test cases. And then we get our numbers. So we get the length of the array, the permutation. We cast it as an int, and we get the actual permutation. And now let's implement the code. So let's say Q, or we want Q to be our output, right? And Q is equal to, this is Q, right? Or this is P, sorry. And this is Q. Now, Q is the last, yes. So first we want to splice P from the first index to the end, right? So we're getting the first index, which is this number, all the way to the end. And we're filling that in Q. So right now we have this is equal to Q, right? This. And so what do we need? We need to add the first index to Q. So we're going to concatenate that by adding, and one, there you go. And then we can print Q. So let's see, let's run that. Another error, we always forget our colons. Okay, so let's just do the first test case with 2 and 1. That one is, let's do a more complicated one. Let's do 5, 1, 2, 3, 4, 5. So 1, 5, 1, 2, 3, 4, 5. So there you go. And a neat trick is to add an asterisk symbol right there and check out what it does. So right here, 5, 1, 2, 3, 4, 5. And that will separate the list with spaces.